Hello everyone, I'm Peter, and as we explore what it takes to create a UI without RAM constraints, I want to show you how to make the most of your memory configuration. More specifically, I want to talk about TouchGFH's smart partial frame buffer, and how you can run impressive animations or UI with only a little bit of RAM. As many of you know, in a traditional embedded system, you always hold a single or even a double frame buffer in RAM, either in the MCU or most commonly in an external RAM. But that's counterproductive when working with small displays and mainstream MCUs. The whole point of a mainstream MCU is to keep a simple design and PCB, lowering the development cost and the bill of materials. Adding external RAM modules is really the opposite of what you are trying to accomplish. That's where a partial frame buffer can be relevant. In a nutshell, this technique takes advantage of the displays that have built-in DRAM. Instead of storing a full frame buffer in embedded or external RAM, the MCU only holds a portion of it and sends it to the DRAM in the display that carries the complete frame buffer. As you can see in this illustration, the display runs through the frame it has in its DRAM, and behind the scenes, TouchGFH handles everything else. That includes rendering only the updated part of the image in each frame that the system stores in the MCU's RAM, and sending that portion of the frame buffer to the display's DRAM. And as the display renders a frame, TouchGFH transfers the new block of frame buffer that will be shown on the next frame. You can see how TouchGFH synchronizes everything in this diagram, where the green represents the current frame content and the blue blocks are the content to be updated in the next frame. The transfer to the display is done with respect to the display scan line to avoid tearing. Blocks 1, 2 and 3 have already been passed by the scan line and have been transferred, while block 4 is still waiting for the scan line to pass before it can be safely transferred. The remaining green area of the DRAM is unchanged by the GUI between the two frames, and it will therefore be displayed again without changes. In fact, let's see how TouchGFH renders a partial frame buffer looking at the simulator in TouchGFH Designer. You can see here that I have a GUI for a round display. As I adjust the volume in the GUI, I use the F2 key to highlight the parts of the frame buffer that TouchGFH updates. These are the gray areas on your screen. As you can see, only a small part of the display is actually being updated and transferred to the display's DRAM. Users feel that the full screen is being animated, when in fact only a small fraction of the circle moves forward or backward, and only the numbers at the center of the screen are changing. Similarly, in this other page showing a green block filling up the screen, users have the impression that the full screen is being updated, when in fact the simulator indicates, thanks to smart partial frame buffers, only the top of the green block and the number at the center are updated, which saves a lot of RAM. Partial frame buffers also require a lot less display bandwidth. And why does that matter? Let's look at two cases. First, a development board with STM32H5 and a display with a resolution of 480 by 320 pixels. Updating the entire display at 60 FPS would require a bandwidth of 148 megabits per second. That's well within the theoretical 200 megabits per second available to update the entire display when using an 8-bit parallel interface at 25 MHz. That's why many choose this display interface when running a GUI. However, in this case, you may still want to use a partial frame buffer strategy to save RAM and lower your bill of materials. There are other cases where the display bandwidth is limiting you in making a full screen update. Take for example an entry-level MCU like our STM32 using 240 by 240 display at 60 FPS. That would require a bandwidth of 55 megabits per second, but this setup only uses a single SPI link capable of only 24 megabits per second. In this particular case, a traditional frame buffer strategy would not be able to meet the required 60 FPS. However, A partial frame buffer updating 40% of the display per frame or less helps you reach 60 FPS without tearing. To see what that looks like in real life, let's take a look at this knob display from our partner Team Source Display, which features an STM32C0. Thanks to the partial frame buffer strategy, it's possible to run a UI that looks smooth even when using numerous screens and animations that appear extensive. So, how can you experiment with partial frame buffer strategy? Let's look at an example project. Just open TouchGFX Designer, select the TSD development board, then Knob Demo Prime, and then click Create. The demo is already set up to take advantage of the partial frame buffer strategy. Just click Run Target. As you can see, TouchGFX automatically downloads the code and loads it onto the board, allowing you to start experimenting immediately. So what can we learn from this demo? Well, one thing to keep in mind is that when using a partial frame buffer strategy, full screen transitions don't usually work well because they can be jarring. However, there are cases where it's okay to break the rules. For example, let's start with our menu. When pressing this item, we transition to a screen full of text. In this particular instance, refreshing the whole display at once creates a rolling window effect. But because it reveals the text piece by piece, the users feel it's a natural transition. However, once the user is back to a list of icons, it's crucial to stay within the bandwidth limits when scrolling, or sharing will be too distracting. That's why in this example, when we are back to this list of icons, the animation happens one step at a time. For example, you can see first that the icons are rolling, then the text is fading and the color glow appears on the side, instead of everything happening at once. It enables the users to experience a rich interface without sacrificing smoothness. When your team is ready, you can start setting up your project in STM32CubeMX. On the left-hand side, if you select Execute TouchGFX, under Frame Buffer Strategy, you can select Partial Frame Buffer for displays with DRAM. Then set the number of blocks and their size. In the example of our knob application running on an STM32C0, we are using the default 3 blocks of 2 KB each. Developers will have to decide what makes sense for them. Choosing a large number of blocks and a significantly larger size will take up more memory. Inversely, making them much smaller may negatively impact performance. Once you're happy with your settings, you can generate the code. If we look at the source code, we see that all the settings we defined in STM32CubeMX reside in the variable many-block allocator. Then developers would write their user code. For instance, in the knob demo, we implemented some functionality for the main menu that runs when the wheel stops animating and it's time for the text to appear. When that's the case, the function starts a fade animation and starts moving in the color gradient. Behind the scenes, TouchGFX uses partial frame buffers to ensure that only the areas that are updated are stored in the embedded RAM before sending them to the display DRAM. That's what makes our partial frame buffer strategy a smart partial frame buffer. This is why partial frame buffers has been highly popular. As you just saw, it is possible to run smooth animations on a mainstream MCU by simply choosing the right strategy in STM32CubeMX and implementing the animations in your application. TouchGFX just takes care of the rest.